My name is Konstantin Vatigan. I am a professor of planetary science at Caltech, and I do all kinds of astrophysics-y planetary studies, including stuff about Planet 9. These are variable transformations. I'll tell you where the Planet 9 boundary lies. It's like that. So everything to the left of that is all Planet 9.
So I'm here to find out about hidden planets and how to find hidden planets with math.
Okay.
So how do we do that? I mean, do you want to start at the beginning of this sort of endeavor, or do you want to jump into Planet 9? Where do you want to start?
Well, let's start at the beginning, because the beginning has a long and beautiful history to it. In its origins dates back to 1781, I believe, when Uranus was first discovered by Herschel. And when Herschel discovered Uranus, he immediately realized that the star that was slowly moving across the sky had actually been imaged many, many times before. And it was a matter of going back to old observations and kind of retracing the orbit that Uranus was following on the sky. And astronomers and mathematicians of the time immediately noticed that there was a problem with the orbit of this newly discovered planet. It was deviating from where it was supposed to be. But a French mathematician by the name of Urbain Le Verrier eventually did this beautiful and very complicated set of calculations that said, okay, if there is a planet there, right, in that part of the sky, then we can explain the anomalous motion of Uranus. And once there was a mathematical prediction of where to look, astronomers were then able to discover Neptune with basically pinpoint accuracy.
How quickly did they find Neptune?
So this is a remarkable story. They found Neptune in one night because they knew exactly where to look. And if you look at the most distant objects in this belt of debris called the Kuiper Belt, all of their orbits kind of point into the same direction.
Is it possible that there are some going in the other direction, we just haven't found them? They're there.
Yeah, of course, that's a great question. Generically, when you search for objects in the night sky, they're always what are called observational biases. You're always limited to finding objects only where you look. So this is a key question that you have to ask, right? Is it that we only found objects that are all pointing that way, right? Their orbits pointing that way because we only looked there. The answer is that there is a chance that this is all a false alarm, okay? And that chance is 1 in 500. There are bodies that occasionally will swing out into other directions. It's more that overall, if you look at it, there is an overall tendency. So here, what we see is a pretty typical kind of simulation of the type that we do. We start the solar system in an initially kind of totally random state where all the objects are pointing everywhere. For scale, these pink circles here are Uranus and Neptune, and this long ellipse, this long pink ellipse is Planet 9. These blue guys, these blue orbits, are long period Kuiper Belt objects, the ones that in the real solar system we see the clustering among, and these gold or greenish ellipses are the more short period, more proximate members of the Kuiper Belt, which are not clustered at all. So it takes a long time, but about 2 billion years into the evolution of the solar system, you begin to see the fact that objects that are collinear with Planet 9 have all been scattered away, removed from the solar system dynamically, and the only kind of remaining members of the distant solar system are the objects that point the opposite way. Again, it's a remarkable gravitational signature, a gravitational one-way sign, if you will, that something is confining these orbits, keeping them clustered and pulling them all into the same plane.
So even though these clusters of asteroid orbits in the Kuiper Belt provide the best evidence for Planet 9, there's a chance that further Kuiper Belt observations will find different unclustered orbits. But regardless, there are two other solar system mysteries that could be explained by the existence of Planet 9. These properties of Planet 9, they seem like kind of nuts. Like a period of 10,000 years, that's not like any of the planets that we have found. So why would we have such a strange planet hanging out there?
Yeah, great question. Indeed, none of this is reminiscent of anything solar system, right? If you, for a second, ignore the period, right, and ask yourself about, say, mass of 5 Earth masses. We don't have anything in the solar system that's 5 Earth masses. We go from 1 to 17 when we go from Earth to Neptune. Is it wild? Actually, turns out this is the most common type of planet in the galaxy that we have discovered around other stars. It may be reversed. The fact that the solar system doesn't host a object which is 5 Earth masses kind of closer to the sun is actually kind of weird. Indeed, 5 Earth masses, as it turns out, is kind of a standard outcome of planet formation. There are more wild things out there, okay? And this is really my favorite aspect of the Planet 9 hypothesis. It's the fact that Planet 9 actively flips orbits on their side. You should not expect to find objects in the solar system that are flipped on their side and are orbiting the sun perpendicular to the planets, and you should definitely not expect objects that are orbiting the solar system the wrong way, so to speak. Yet we find them, right? They exist in the Kuiper belt. Right? And this has actually been a problem since before Planet 9 was even a thought. Planet 9 has this intriguing mode of dynamical evolution that it instills upon distant orbits, where it takes them and at the expense of kind of circularizing these distant objects, right, making their orbits less elliptical, flips them upside down and then makes them more elliptical again. It's a complicated dynamical evolution, and really at a detailed level you have to go to the computer simulations to understand how it works. But the key kind of product of the existence of Planet 9 is the expectation that such objects would exist, and we see them. And there isn't another kind of natural mechanism to generate these highly inclined bodies.